Yeah, so for this session, as OpenSense is normally focused to security, I will drop the basics. So let me start sharing my screen. Let me see. Okay, I think that you can see my screen now. Yes. Okay. So about Frontend for Web3 development. Just before I start digging into the Web3 part, I want to just do some basics about Frontend. I guess that most of you know that on the browser, the only runs HTML, CSS, and JS. I'm not gonna go into WebAssembly right now because that's quite advanced stuff. So let's just dig into this basic stuff. So on the browser, you write the applications using these three languages: HTML, CSS, and JS. And this come from a long ago that started with Internet Explorer. It's a very long story that's not very important right now. So I'll just advance to the part where the backend guys wanted to use JavaScript, and then they created Node.js. And along Node.js, we had npm, that it's a package manager. So you can install libraries like Web3.js or Ethers or any other stuff. And what happened? That there were cool stuff on the backend that people wanted to use on the front end, and you cannot do on the front end. You cannot require modules. You cannot do the same stuff as in Node.js. So what's the way to use the modules on the browser? So that's Webpack. That Webpack for me was before starting using React was something completely what the fuck, because it's why do we need this? And Webpack, what it does is it just gets the code from all the modules that you install and add them to a single file. So on this way, you can just import that JS file into the HTML, and you don't need to require, and you can use it. That's one cool thing about Webpack. Another cool thing about Webpack is that it minifies your code. What does it mean? That when someone loads your website on their phone or on their computer, they need to load the HTML, the CSS, and the JavaScript. So in this case, minifying all the amount of code that the browser gets makes the website faster. So you minify it, and minify means that, for example, if you have very long variable names, you shorten them and you save some bytes. If you have semicolons, it removes them. But this is done normally by Webpack. You don't need to do it by yourself. So this is a quite cool feature. And then after Webpack, we have Babel. And this Babel thing, it's due to compatibility, because right now we have very cool stuff on JavaScript that it was not before. Coding in JavaScript before was really a pain, but there are still browsers that don't use these new features that are cool. So you need something that transpile the code that you have written to the old versions of JavaScript. And that's where Babel comes in. This is very similar to TypeScript, because TypeScript, what it does is transpile your transpit code to JavaScript. But there's a difference between Babel and TypeScript. TypeScript check the types, so because you write types for your JavaScript files, and that make it slower than Babel, because Babel doesn't do that. It doesn't do the type checking. It just transpile. So it's cool, like, to know both of them, TypeScript and Babel, for transpiling, and you can use both. And normally both are used because you already have code in transpiling pipelines with Babel, but you're also adding TypeScript. And due to the difficulty of doing applications in pure JavaScript, there were multiple frameworks that were born. Where the most popular is React, that I guess that it's the most known by everyone. At least it's the most known by me, and the one that I found the most documentation and tools. So that was React. I think that helped a lot of people that were newbie like me when I started on just checking on all this stuff about blockchain and helping me just to start doing websites and having confidence on myself. So now that we have explained some basics about frontend, let's explain of what is the app or a Web3 app. So a Web3 app is a website that may use the technologies above, but for sure use the HTML, CSS, and JS. And what makes a normal website or a normal app to a Web3 app or to a app is that it connects to a node. It may be an Ethereum node or to another chain that it's EVM, but it's basically a website that has some kind of middleware that connects to an Ethereum node and sends JSON RPC request. That is the way to contact to an Ethereum node. So in the case of the browser, we have window Ethereum, that is like the standard, but window.ethereum is not like the standard itself. The standard itself is the Ethereum Improvement Proposal 1993 that it defines the way that libraries for the browser interacts with the Ethereum node. And this Ethereum Improvement Proposal was made by the MetaMask team. So that's one of the reasons why it's so extended, because before MetaMask, any wallet provider was just implementing their own way to communicate with Ethereum node. For example, there was Mist before, and there was also Parity. That I think it's famous for a hack that they had more than because they were a wallet, and they were using window.web3 instead of window.ethereum, but the both implementations were different. So it was like, okay, so we are going in a separate ways, so let's use go together. So I have here the Ethereum improvement proposal, and as you can see, yeah, exactly, Ethereum provider JavaScript API. It's quite old, but as you can see, it doesn't have a stagnant. It doesn't have anything right retired. So it's like it's one of the few that I see from front end that it doesn't have anything weird. And you can find the specification and the events and all this stuff. But I have a demo in code that I will show you. But just before digging into the code, I want to show you talk about two more Ethereum improvement proposals. One is this first pack of improvement proposal is the add chain and switch chain that, as you can see, is the 3085 and the 3326. And this is the standard to add and to switch the wallet on of your injected wallet on your, in this case, in MetaMask. And something that I found curious from the ape, because I found that some wallets did it differently, but I didn't know why. And in the ape, so because when you add a wallet, there are sometimes, for example, MetaMask, that when you add a new chain, it switches. You click on approve, you add it to your MetaMask, and then it switches. But there are other wallets that I tried before. I don't remember which one now that didn't do it. And I just went into the ape, and it says this specification does not mandate that the wallet switches its active or currently selected chain after a successful request. So it's just like it depends on the wallet implementation. So when you're implementing the code, if you're using other wallets different than MetaMask, this is something that you should take care about. I think that not many people implement this stuff by hand. For example, you can use Rainbow or you can use WAGMI, and it will do it for you automatically. But it's kind of cool just to know how to do it, because for this one, exactly for the add chain, it might raise some security concerns, because the way that you are adding the Ethereum, the chain, the different chain than Ethereum, is adding some params. I mean, you're passing an object that has some keys that you need to fill, and you can just, for example, change the RPC to your own RPC, or just you can just like fake the chain that you are adding. So this is part, I mean, this is responsibility of the wallet to verify that the info provided is okay. And MetaMask, if you try to add a chain to MetaMask that MetaMask doesn't recognize properly, it will show it. So that's something that's cool for MetaMask. I didn't check for Brave Wallet. I didn't check it, and not for Coinbase neither. So that's kind of cool. But the switch chain, it's kind of similar. I'm not gonna dig pretty much, but it's just you pass the chain ID, and it prompts MetaMask to change the MetaMask change. Something to take in account is that if you don't have the chain added, it will fail. So it's better to just first try to add the chain, let it fail in case it fails, and then try to switch the chain. But if you can add the chain, it will most probably not fail. So the last Ethereum improvement proposal I wanted to talk about just before digging into demos and showing more sites that implements this Web3 approach is signing with Ethereum. That it has for me it's very cool, but it well sorry, I jumped at the Ethereum request account. I will just go for it later. The signing with Ethereum, what it does, it provides an experience like with OAuth. That, for example, that when you go to a website and it says sign in with Discord, sign in with Google, sign in with GitHub, or something like that, that you use external providers to sign in. So this is the idea of signing with Ethereum. So the main the implementation of this, let me show you an implementation of this because I think it's very cool. Launch app, consumer app. See, Last API is just an old provider. I recommend it. It's very cool because it provides free free AP keys for their nodes, and they have they have the archive, so you can fork the network with it, like if it's Alchemy or Infura, so quite cool. But let's go with signing with Ethereum. So signing with Ethereum, what it does is ask you to sign a message, and then on the back end, the dApp checks if this message is signed by this user. So normally, when the backend generates this kind of message, click sign in to sign in, no password needed. This request, blah blah blah, and then there's this unique identifier and the address. So it can be checked on the backend. Why is this not more widely implemented? Well, because there are concerns that I've not verified by myself, but there's a discussion on the Ethereum forum about this, about the security of signing plain messages. Because what you're signing is just a message, a plain message, and not an A712, I think. The typed data one. It's not that one, because for the typed data one, it's like not user friendly for MetaMask, because from MetaMask, when you sign typed data, it shows this kind of object. Let me show you. Here it is. Because there are some cool no, I forgot. See, let me check. See, here's a bunch of stuff. Kind of cool. I recommend the reading. So see, this is as we did for logging into Blast API, and this is the message that, well, this is what will be shown on the wallet if you use a typed data. Using typed data will be far better for this, but as you can see, it's like it's not easy for the user to understand. So we have this kind of challenge slash war about security versus UX UI. So right now you see that it's right now on review. So it has been on review, I think, for like since October 21. And but there's interest because just every few weeks there's people just discussing it, and I think that this kind of improvement proposals will lead to more adoption because it will ease the way to use Ethereum apps. There are also another Ethereum proposals like for getting the wallet permissions and for setting wallet permissions, but it is also something that from the UX UI you need a lot of work from the wallet provider, and that's not like something that comes from the community itself. It comes from the companies and it depends from their interests. So just going back, I just missed one of the important ones, that is la Ethereum request accounts, because this is like the most famous one, the one used for the connect button on the dApps. So what this ape proposes, I didn't have it here. Oh, ape 102. So what this ape proposes is to have an Ethereum call that will ask the user to connect their wallet. And something cool that I like is that they proposed this pseudocode that is like that without knowing about this ape, this is how everyone does it. All this is how I was doing it just before knowing about the improvement proposal. That is, it started the app. If there's the provider, so if there's MetaMask installed, something like that, request the account. If user approves the connect account, then resolve the account access. That does it mean that it enables the window Ethereum stuff, and then you continue. If the user rejects, then there's nothing to continue. So there's the only website, no Web3. And if there's no window Ethereum, there's no Web3 neither. So it's like everyone. I mean, if you go to any site, is something like this, unless there you need data from the chain without having the user connecting the MetaMask. For example, if you go to the Fijama and you want to check stuff or to Etherscan, you don't want to connect your MetaMask. You only want to use see data. And you can see an example here that if you send, that now it's not send, now it's request, because I think that send has been deprecated. So now that I have run over the theory, let's go through the code and through the examples that I think is the cool stuff. So thank you for listening to all these texts. So let's go with the first demo. This demo is a very basic demo with plain JavaScript and to interact with MetaMask. And we will play with the improvement proposals we've spoken with, but not with signing with Ethereum, because that was like a lot of work and I didn't have time for it. So let's just dig into this code. So for MetaMask, for this one, what we are doing is just a very basic one, connecting the wallet, connecting MetaMask, asking to connect, and then it shows your account, it shows the chain that I'm right now on a chain that will be unknown by most of you, that is Moonbase Alpha, that is just a testnet from Moonbeam approaching on Polkadot. And I chose this because it was the one that I had balance, so I could check the balance. So you see right now that you're connected, and let's check the what I was telling you about switching the chains and adding as the chain. So you can see that this switch the chains. It changed. Now it shows the proper information. See, and now it's asking to approve the data. This will allow network to be used within MetaMask. MetaMask does not verify custom network. It's like, okay, be careful from everything that you add here. You approve, and then it asks to switch the network. Okay, very cool. Let's see the code. Okay, as you can see right now, I hope you can see it properly. I add some zoom, so I hope you can see it properly. As you can see, this is just HTML. And here we have the just a very simple index.js. I get all the elements from the HTML, so I can add text or add functions. So if you click the button, it just does this stuff. So this will be like the function that does this. You know that it's just here between the Ethereum node and the provider. So what we are doing is we are calling the provider, and with the provider we're doing a request. And JSON represent request, what it requires is the method and some parameters. And the parameters are always a chain. So let me show you an example of this. So just before digging into the function, we check if window Ethereum it's there. And if it's not there, let's just tick, 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 tick. See, no injected wallet. Please install MetaMask. So we'll check it. And if not, then let's just do some stuff. One thing that I didn't mention is that there are also event listeners on the window Ethereum object. What is an event listener? So on the website, every time there something happens, I mean, you can like control it. So you can like drop an event and you can listen to this event. So window Ethereum exposes some events. For example, when you change the chain, or when you disconnect, or when you connect, that you can listen on them, and thanks to that, you can like provide more insightful UX UI experience to the people. So, for example, when I switch the chain, as this is just plain JavaScript, and I don't want the user to see the old values once he has changed the change, I just reload the page. So he needs to connect again, and once he's connected again, he sees the updated values. And another cooler stuff, just before digging into the rest of our stuff, there's another thing that I think it's very cool for the UX UI experience, that is the auto reconnect. For example, there are the apps that you access to the app, you click on the connect wallet button, you refresh the page, and you need to click on the connect button again. And I mean, there's it's not a reason to think that the app is bad or anything. There's something then wrong, because this is how it's done. But I like the auto reconnect feature. And one way to do this is just to request again the user to connect. So MetaMask remembers it has been connected to this website, and if you try to connect again, it will just connect automatically, so you don't need to click on the button. So here you can see that I just send a call, I send the window Ethereum, I just ask for the accounts, it has any accounts, and then it just connects and updates the data. So let's dig into some calls that you can do to an Ethereum node to get information for your dApp. So the first one is the one to connect. That is the Ethereum request account. So as you can see, we send a call. That is the provider. That is the window of Ethereum, the method, and the params. That there are no params because you're requesting the user to connect. And what the window Ethereum specify, I don't think if it's the window Ethereum or just MetaMask, it returns an array of addresses that I don't know why it only returns one, but I guess that the idea was that you could like connect with multiple accounts to the same dApp. So that's why you have an array. I don't know. I'm just like having some imagination. So let's continue. Uh, so for the next information, for example, we have get balance that will return the balance from from an account that you pass. And now that we have the account, we can get the balance. We can get the chain ID that it's also an Ethereum improvement proposal that I didn't mention because I didn't think it's quite worth to mention all of it, and also to get the block number. One thing that you need to take in account is that this doesn't give you the value that it's prepared to be shown on the HTML. So you need to format it. For example, the balance, it returns an hexadecimal value. So you need to parse it. And then you need to calculate, to do the math to turn it into Ether, because it will return the way value. And these two fixes that just do not have like 10 decimals, because I did a transaction that costs very few gas, and then I have all my UX UI broken because I have a very big number on my how can I say it, on my wallet. And for the block, the same. It returns an hexadecimal value, and then you parse it. So this is quite straightforward. It's quite the part from the Web3 is the easy part in my opinion, and the difficult part is just have everything to be shown like you like. Because you can see right now, you can see the chain, you can see the block, that it's beautifully separated by commas, and you can see the balance that is not like a very chunk, a very big amount of numbers. You see, MetaMask just sets four digits, and I said two. So whatever, this is public. I will show the repo later, so in case that you want just check it on and play by yourself. And I made the same demo, but instead of just playing JavaScript, I did it with React, because I think this is like what most people will see if they dig into an application or if they want to use it. So what I did is use installing WAGMI and VM. That, for those that doesn't know, apart that from a meme that we are all gonna make it, it's a very cool library to do front-end applications, because it has like a lot of calls that are already done. So for example, use account, and you can check the address of if it's connected or if it's disconnected, or only use connect. So you don't need like to check if window Ethereum exists or not. Use block number, so you don't need to write it to parse the stuff yourself. There's like a lot of stuff. You can sign messages, you can sign typed data. That this is super cool. That they also add. I have some more demos with this, but let's just go back to this demo. So as you can see, we connect, and it's pretty similar to the previous one. We got the address, we got the balance. That I didn't parse it because I wanted to show the difference, that this is super ugly compared to this. It's more, I mean, maybe I'm just very maniatic, but I think that it's better. And you could write a function in case that the guy has like 0.001, like just drop zeros until there's one number, but that's just poor front end. So let's go see the block. It's hard to read. Okay, it's how million? Okay, 1, 2, 3, 1, 2, 3. Okay, 4 million. Okay, and you can see right now. Then you're. Oh, thank you. I have. I mean, this is not. I mean, this is not the cool part. This is not the cool part. This is the boring part. Because it's like use for implementation of code. Because if we go here, I I I wanted to use like the last version of everything. So I use there's a React like library slash framework called Next.js that is like now the standard for creating the React apps because create React app has been deprecated. So I wanted to use it. So I had to do some stuff because what Next.js does now, it it generates the page on the server and then it drop it on the client. So for all this Web3 stuff that depends only on the client, you need to like drop it on client components. And as you can see, this is all the configuration from WAGMI that I think it's super cool because, for example, let's say we want to add Binance. So I'll just add Binance. Wait, why it's not? Ah, there's no Binance. Well, there's our, let's add Arbitrum. And you can just add Arbitrum here. Ah, right. Let's just add it to. Okay, and you can just add change to WAGMI. And now if I reconnect, yeah, exactly. And now you see, you can just add the new change. Switch the network, I already had them added. And what it's cool about WAGMI and VM that it provides you like all the stuff when you like want to connect. It returns you like all the stuff that you need to do to check if it's connected or not. So you render if it's loading, you can just return a loading. If it's not connected, you can just return connected, and you don't need to do it by yourself. You can see its error, it's idle. So for example, if this error, you can do something like return and then get the error and do like this, and then you will. I mean, it will be like super easy, and you only need a few lines to create a Web3 app. So plain.js, it's cool to learn how stuff work, but when you want to be fast on development, it's good to know about tools that are already done that are cool, and WAGMI and VM that WAGMI relies on VM that it's like others are very cool for this one. So this was these two were the demos that I made for the Ethereum improvement proposals, and I wanted to drop some more examples about Web3 apps. I'm showing you some examples that I've made along this last 2 years and a half that I've been doing this kind of stuff. So this application is an application that it's multi-chain, and I made the switch Ethereum chain manually, and this is like the first time that I did this stuff. And what this application does is allow you to send a message to another wallet. So for example, you will like, I don't know. Well, let me see. Moonbase Alpha, Switch Ethereum. I mean, this is like pretty old. This is like plain React and CSS. It's Bootstrap. So Bootstrap. And see, some cool stuff that I wanted to show is this UX UI thing that, for example, now I'm waiting for your transaction. So if I just minimize this, I have some feedback about what's happening. And I also have this spinner here, so it's like, okay, something is happening. Oh, I have something here in MetaMask. So let's just aggressive. And now waiting for transaction is waiting and waiting. And what I did for this is once the transaction is done, it just uh, concatenates the the hash, as you can see, with the block explorer, and then you can just see the transaction. So let's go UTF. Hello, Vincent. Yeah, this is just the point of. I mean, it's
Pretty
it's
cool,
not
bro.
the
You
most
know,
sophisticated thing,
really cool.
but it doesn't escalate very well because just don't try to add more than two sentences.
You could use Solity's libzip to make the message even smaller.
Yeah, yeah. I wish I knew about it when I made this. Actually, and yeah, and I made like a second version because this one is like, okay, this was like very cool, making it all by hand if the repo is open, so you will see like a lot of spaghetti there. Well, most of my GitHub it's spaghetti, so I hope you don't mind. And I made this use instead of Bootstrap, I use Tailwind, and instead of just using my own wallet implementation, I used Rainbow that as you can see it's very cooler, it's super cool, and something that it's even cooler that it works on phone. I mean, you see how it looks on phone. I mean, I can compete. I mean, my CSS is it's just bad. My CSS is just bad compared to this. So you can connect and it connects and you can do just the same. I don't know who is this. Hello open sense from the other one. So for example, you don't need a spinners or something like that to do it like you are giving feedback to the people. For example, you can just change the cursor. As you can see, it's like, okay, I cannot sign. What is happening? Oh, okay, I'm just blind. So you can just saying, okay, your message has been sent. Check your transaction or block explorer. So it's like you don't need to make super sophisticated stuff because all people can do is you come here and do this, go to other scan, paste the transaction hash, and just wait. So this I wanted like to show you different ways to do this stuff and just to flex about night mode because night mode is also nice. It's also it's something that it's not like it's not important, but with more important that it should. At least I do because I just love like to do this and used to
Switch the
F5 and
lights.
no, yeah, and I wanted to remember what I've chosen, right? See, because if I F5 and I want dark mode, I want dark mode. Even if my system settings it's dark mode, that if just as a curiosity for CSS, that for dark mode there's a CSS property that it's called prefers color scheme. Then you can choose if you use light, dark, or use the system. So that's one of the ways to do
Nice.
this stuff. So
This is pretty cool, man.
I had some more. For example, this one it's a Web3 app that doesn't require MetaMask connection. And what this does is you paste an Ethereum address and it looks on all the chains that has either as their as their native currency and it just
Nice.
tells you if
How
you
many
have
chains?
the ones that are on VM. Because what I did, I mean, I'm so fucking lazy that I didn't want to just write them by hand.
I see.
So
I see.
I imported VM. I mean, because I imported this. Let me show you. You see here that it's WAGMI chains. So this
Yes.
WAGMI chains from VM. So I just like got all the
Nice.
keys from here
This is really useful, by the
and
way.
and check it. If native currency if is ETH, then add it here. So let me just check if on GitHub. Hey, oh, I've not logged in. Okay.
Where's mine
So
here?
Where's my either? Here. Yes. So if you go to here, library, balances, see this is some kind of half spaghetti, half smart, I would say. So I get all the chains and then I do all this. Well, I treat the object, I turn it into an array, then, just to check if it contains if, and then I return all these clients, and then I get all the either balance. So I create just an
Nice.
array of promises and wait until all the promises are done, and then I return it.
Would be nice if you
So
could add
promise,
like rapid ether too.
yeah, that will be a good one. I thought about it. Actually, I have another one that is similar here that is using ethers. Let here. This is pretty similar, but using ethers instead of VM. So this does the same, but it also takes a lot of, this is an npm library. You can use it on your web app, so you can just paste an address and it will return it. So, but it's more work just for WE because as it's an ERC20 token, you need like to add the ABI. I mean, it's just a bit more work, but as I told you, I'm quite lazy
Yeah, everybody,
for,
bro.
for that. So, and this is another example using WAGMI. I wanted to show at least one demo using, well, interacted with a contract. So what this does is interact with a precompile on Moonbeam that allows you to execute gasless transactions. So what I do is in the backend I sign the transaction and then I pay transaction with my own account and I mint the token. And you can see what I added just like a bit feedback is just a spinner waiting.
Yes.
And if I reject, user rejected the
Wow.
request. Okay, that's your.
Nice.
And you see, and this is not something hard. I mean, the hard thing is to make it beautiful. That's the hard thing.
This is the hard
But
part.
thanks to that's the hard part.
Mm.
So see transaction send. I see you don't even need to handle the if the transaction is just loading or not because the user will just go to MetaMask. I mean, it's pretty cool to have it on the same page, everything like very cool. Like it adds a lot of value to the website. But if you like, for example, want to do a demo or if you want to do an MVP, I think that just adding very little stuff can add a lot of value just on the front end
Nice.
instead of just mint and just wait. And that was like most of my demos from the standard Web3 part. I also wanted to mention some stuff about, for example, how Uniswap manage the connection. For example, right now we are connected to Moonbase Alpha. Moonbase Alpha is not compatible with MetaMask. So let me see what MetaMask does. What Uniswap does. It allows you to connect, but it says, "Hey, this is not connected," and it shows you the ones that you can connect. Because something that you could do is like disable the connect button in case that you went multi-chain and the user is not connected, then you will do something like connect to the following wallet and then
Mm.
connect.
There's any
But
way
see,
to use the same wallet, like to do the same transactions on both chains at once, like signing from the same wallet. Like there's no. Imagine I wanted to do the same interaction in 10 different chains, but using the MetaMask or something.
I mean, what you could do, because for example, with MetaMask, I'm not sure because I mean, you can like send a transaction, and while it's waiting to be mined or to be confirmed, you can change the MetaMask and send another transaction, and it will be sent. I mean, it's not parallel, but I mean, it can be like be on the mempool on the same time on different chains. That yes, what you could do like allow the user. There's something that comes from my mind. is to have two different wallets. Because, for example, I have here Talisman, that what Talisman does is just the same as, well, let me console that clear. Window.talisman is just the same as MetaMask. So let me just do the same as with MetaMask. I not request method params. So this what it is going to do is just to Ismael, please. Window dot talisman dot if dot request method dot eth request accounts and params. I'll just copy in case. See, and it opens Talisman. So you could
Nice.
like have choose provider something like const metamask equal window.ethereum and const talisman equal window.talisman. And you could like leverage, like for example, well, right now it's like just broken. Okay, so you could like have these two, and I think that for example for Polkadot, because Talisman, what it has is like this double this double nature that you can sign transactions on Polkadot, but also on Ethereum chains.
Nice.
So this is like the multi-chain approach is like very different on different chains depending on their on their nature. For example, Avalanche. I mean, if you will go multi-chain with the C chain that is the EVM chain and the another sub-chain, you will like handle this stuff. And I think one of the most popular reasons against the L2 scaling of Ethereum is the UX UI experience. Because right now you have Ethereum, you have Arbitrum, you have Optimism, you have Cairo,
So many options,
you
right?
have you have a lot of things, and just imagine like Ethereum and like you need to scroll like you have
Yeah,
you
you're gonna
have
be like three
a
pages.
big monitor and you need to scroll through all of it. Okay, what which one it is, and we'll just let's imagine. I mean, we will run out of colors,
Yeah, it's
you
true,
know.
man.
So we will start having like four ones that have this color. I don't know.
Yeah, man. I mean,
It's a mess. It's a mess. So the multi-chain stuff, it's
don't
quite
you?
hard. And
We should have like an EIP for that, right? For multi-chain like interoperation. But I think those are the shards Vitalik keeps talking about.
yeah, but I think but it's also, I mean, there's like two approaches about it because this is the multi-chain and also the cross-chain. And I also wanted to show you a cross-chain one because Ethereum is multi-chain. But what about the cross-chain one?
Wow.
So this is a squid router. A squid router is a DEX that allows you to do swaps on different chains. So you are doing you are sending one transaction that will be completed in two different consensus. This is like
Wow.
it's like mind blowing, and the way it's done is like you send a transaction on the origin chain, and then there's a relayer on the middle that sends the transaction on the other chain. So it's
Oh, that's
like
really
you
cool,
need to
man.
trust you need to trust the thing in the middle. And what the skid uses is a technology using Axelar that is like in a lot of EVM chains, also on Cosmos, and it's a cool way to do this stuff. So something that I wanted to show you is, as you can see, is it shows you all the available chains. It has like a lot. This is the thing that I told you. Wow, there's a lot of chains.
Wow.
This is awful, and I see. I mean, there's no other way to do it. There's no other way to do it. But at least you have like a search bar that
Wow.
it helps. At least. So for example, let's go to Moonbeam, and then it told you, hey, you need to switch the network. Hey, you need to switch the network. So it told you to switch the network, and then
But this is a
you can
bridge,
use this is a swap.
so you can do
This is a swap.
multi-chain swap.
Yeah, cross chain. I mean, it's Crosschain, and this is powered by Axelar. Oh, did I click on translate? I didn't want to translate. So this is Axelar, and these are the docs. Let me see if there are like some kind of picture. Wait, I remember having pictures here. Wait, I don't know. There were some cool pictures. Okay. Overview. General message passing. So with GMP, you can call a contract on chain B from chain A, call a contract on chain B from chain A, and attach some tokens. So they allow you to like send a transaction from chain A to chain B, and you can add a payload, and it will also send the tokens. But to send the tokens, it's like a wrapper version. So for example, for USDC, you send USDC, and what you receive on the other chain, it the Axelar USDC. You know, like on Warhol, that if you go to Wormhole and transfer from one chain to the other, it's the Wormhole one. But the cool thing about the Squid is that you can choose. So you can use, see, it says
Yeah.
Axelar USDC and USDC. And why and how this is done? Because it gets the liquidity from other providers on the other chain.
I
As you can see,
see.
and something that is cool is that you don't have enough glimmer that it's the token from Moonbeam to cover the estimated gas cost. Make sure you have more than 4 glimmer. That is like, what the fuck? I mean,
Nothing.
cross chain. I mean, no, I mean, it's nothing in terms of dollars, but for me, it hurts because, for example, let's say that the Solidity guy sees that. It's like, what? No.
Yes, sure, it's too much.
No,
Hi
but
guys,
I
hi
mean,
guys.
it makes sense. I guess, but it makes sense because you are sending a transaction on